and welcome back for our last video of our wells hydraulics course. And this last video I just want to show you a couple examples of MODFLOW models within the GMS software. So I'll use if you go on the Aquavio website, you can find all tutorials for all the packages with MODFLOW, basically how to use different packages, how to use their interface, and here I just want to showcase again thinking about wells, but more generally about MODFLOW, what can you do within the GMS interface. This first example here is, you can see non-vertical wells and pump curves. So this is some pretty advanced concepts for wells hydraulics, where basically you can model those multi-well fields as non-vertical, so horizontal wells essentially. So if you look at this figure here, this is sort of the result of the simulation. And I'm sorry, there's a lot of reflection here on my, it's getting dark outside, so I'm just trying to get some lighting, but it's not great, sorry. Yeah, so you can see here, it's essentially a foundation, construction site dewatering problem, where you can see the water table is going down on the construction site. And again, all the steps, so this is really how they're, you can see it's Aquavio, those how-tos or those guides are very well done essentially, so you can really go to their website if you're interested. Again, you can get a free trial version, otherwise it's a proprietary software, so you have to pay for a license, but it's a really good software skin for the MODFLOW software. And here's the setup, so you can see here the construction site and the horizontal well that you want to model like a multi-point, dewatering system essentially. And then all the setup, you can see the grid, all the setup is detailed, step by step essentially in those. And this is the result of your, the head for that site. So again, this is just an advanced concept problem that you can solve with Aquavio or with MODFLOW. Another example I want to give you is this one here, if I can open it. There it is. What they call the conceptual models, and these are very neat because you can use as you can see here, you can use a topographic map essentially, which you can see here in the background, and you can literally draw your the area you want to model, and then add different features to the model, and then calculate the groundwater flow for that model. So here you can see there's a couple of streams in green, and I'm sorry I can't really I can actually here. Excuse me, red here. So you can see here that would be a stream, there's another stream here, another stream here. The boundaries are given, there's a well here and a well here. And you can model this whole whole area really efficiently within MODFLOW. There's a river down here, excuse me, let me, yeah. And do blue. Okay, here, down here, actually this whole boundary you can see is a stream in the valley, right? And then it continues here, and then it came from here apparently, right? So you can see that one of the boundaries is a stream, again, well here, few stream crossing, into, going into the main stem. And you can see here the head contours, right? And you can see how that well is modifying that, making a cell here around it, right? So everything is really simple. And again, if we go into, if we go into the document, step by step again. So here is the overall area that we're trying to model. The rivers, the two wells we want to put, the limestone outcrop, the 3 creeks I outlined before, and then getting started. So again, it's really a step-by-step. Launch GMS, if it's running, go to File, New, etc. So it's really a push button, step-by-step guide again, import the map. So again, there's like, you know, web directories essentially where you can download data, especially like topographic maps or DM and etc. etc. So all the GIS essentially information you would need to set up your hydraulic model. So again, you download the map, and then once you have the map, literally you can just, you know, draw on it. So you set up the boundaries that you want. So here's an example, and then put the streams. So they'll tell you how to, you know, set up those as streams essentially, or as recharge boundaries. So you put the 3 streams in there. There they are. Now you have nodes, you know, across. So these purple are, you know, one stream down here, another stream, you know, at the southern border here. Let me highlight. So this stream here, and then you put those in your domain. So now you have all the stream boundaries, right? Oops. There they are. Now you put the wells. Okay, one well here, one well here. Sorry. And you put the grid on. So here's the square domain that, you know, that includes your subdomain or the domain you want to model. And then finally you put the grid. So you'll recognize, you know, when we do Excel, it's exactly the same, right? You can see there's some grid refinement around the wells, right? So around the 2 wells, you're trying to get a finer grid so you can have a better definition, if you will, of your, you know, or a better mathematical solution on the grid. Finite differences, grid active, and again, step by step. And then finally you run the model and you can see the contours, so the head, you know, the equipotentials, the head contours, just like we've had in Excel before. So you're essentially solving that flow equation, you know, on those cells, you know, across this whole model, right? So again, you can see how, you know, simple or user-friendly at least these interfaces, you know, make the flow equations. I mean, we went through the whole thing, right, in the first and second course here, where we solve those equations, you know, manually. We describe those equations, etc., etc. But you can see how, you know, you can hide all this science essentially, or all the code, the MODFLOW code from the USGS, you know, behind an engine where you can essentially click on things and, you know, incorporate. So it's a much more, you know, modern, user-friendly way to do things, where you just essentially go on the menus, you know, draw your boundaries, you know, generate the grid, and then you tell the model to basically solve those equations on that grid. And this is just a top view, but of course you can have, you know, several layers in the depth as well, in the 3rd dimension. Different hydraulic conductivities. Like I said, it can be a heterogeneous aquifer, so you can have all sorts of rocks and formations, right, in the domain. So it's a really powerful tool, and I hope this illustrates how you can model, you know, entire domain, not only wells. Here you have 2 wells, but, you know, see how those wells interact with the aquifers around them in general and the region. All right. This is it for this course, and I'll see you now in the 3rd 1-credit course, which is all about contamination. So we'll use this domain actually in that course, and we'll add a landfill here. And what happens is, if the landfill leaks into this larger domain, what happens to the well, what happens to the stream, what happens to everything. I thank you, and I'll see you in the next video. Thank you.